Everybody. I'd like to give you a brief overview of remote method invocation, chapter 43 of my book, Java for Programmers. You can get more information about this by going to www.docjava.com. RMI is a mechanism for doing distributed computation. This is true concurrent computing. That means two things can happen at the same time, as opposed to multi-threading, which simulates concurrency, or multitasking, which is another way to simulate concurrency. This is true concurrency. With RMI, typically what you have is a client that uses an RMI invocation to a remote host. And the remote host typically runs some sort of a registry which registers its services, and RMI is used to discover those services in the registry and then can make direct invocations to the server. The registry gives you what's called a lookup service, very similar to domain name services, and it can list all of the services available at the on the remote host. Typically what you're doing is when you make an invocation, you call an interface called a stub, and the stub from the client point of view goes through what's known as a remote reference layer. This is a layer that sits on top of the transport layer, so it uses TCP/IP. Then on the server we have a skeleton which implements the stub and does all of the computations and returns a result. Data types which are passed are strongly typed. In addition, you can return instances and you can pass instances in, but the server needs to know about all of the classes that are going to be referenced by the client. That's part of the configuration issue, which we'll address in a little bit later. The RMI architecture makes use of the so-called stub, which allows you to marshal your parameters to the receiver across the TCP/IP channel. The receiver then proceeds to run the application on the server and then do some computation and return instances back to the stub. The TCP/IP link essentially gives you a stop and wait protocol, which means that after the invocation, the right-hand side of the equal sign basically blocks the main thread of execution until the computation is completed, at which point the left-hand side of the equal sign is returned. So here it says x equals if dot m something or other, and that causes a call to a stub which goes out to a link. It has to stop and wait for the skeleton to marshal the parameters, invoke the method m, then return the answer back through the stub, and then return to the equal sign. So from the client point of view, we're using a registry which can run either on the client or on the server, and the server can go and access that registry and start to register some of the services at runtime. So one of the things you have to think about is sort of like the steps for doing RMI. You want to define interfaces for the remote classes and then compile the interfaces. You want to create and compile classes that implement the interfaces. You want to use an RMI compiler to create stubs from the classes, and the implementations will have to be distributed to the server. The server application will need to have these things compiled either on the server or in advance of their distribution. You'll have to start the RMI registry, start the server application, register the application with the registry, then you can do your invocation on the client. So after you're done with that, you create a client program that accesses the remote interface, you compile the client, and you test the client program. So all of this assumes that your services are all going to be debugged before they're distributed. The interfaces subclass or extend the java.rmi remote interface, and then they declare methods that can be invoked remotely, and then the remote interface doesn't have any particular operations. The remote object is an instance of something that implements the remote interface. That's a class that essentially has its own list of operations that you may like to implement. RMI doesn't have any mechanisms for attributes. The interfaces can't define the attributes. In order to provide access to instance variables of server objects, designers have to write access operations, getters, setters, things like this. Parameters of remote methods must not include types of remote classes. The operation should only have atomic, non-remote types and remote interfaces. And so now at this point, I think it might be good to try and do a little bit of a quick demo. So let's take a look at something that's computable. So we define a very simple interface now. This is called the computable interface, and that extends the RMI remote interface. And what it does is it returns an instance of something that's serializable when someone invokes compute. So you say compute and it returns an answer. We don't quite know what they're computing, but we do know it can throw a remote exception. Also on the server we can call printline and pass in something serializable, and what printline will do is invoke the print method there. And it too can throw a remote exception. So the interface is pretty simple. It does a compute, it does a print. The server itself, it has to implement the computable interface, and it also implements a unicast remote object, which means it's going to use TCP/IP and a fixed IP address with a fixed port in order to be able to go out to the compute server and try and gain access to its services. So here comes compute, and what compute does is it returns a string called "You have reached Doug's computer." That's great. And here's a printline method that essentially just calls printline on the server. And if what you want to do is run the service on the computer, well, we give you a main method that essentially handles all of the housekeeping. First thing we want to do is get the local host, and then we're going to look up the server and bind it with the registry. So to get the local host, we'll get the local host address, we'll print it out, and we'll do that so that we can know where to connect to, because we'll have to know where the server's running. To get the local host, we'll just call inet get localhost to look up the server and bind it with the registry. We'll make an instance of the compute server. That's the class that contains this main method. We'll get our IP address and say we're servicing on the IP address. And we'll provide a URL for the compute server. And we'll take that registry, and we're going to have to get an RMI registry to do a binding, get our URL, and then bind the compute server with it so that people will know how to reach us. So this is the directory service that we're using. And then we'll just say server is started, and we'll print it out. So the server has to start first. And then comes the compute client. Now that's going to make use of the service, and so what it does is it grabs onto the security manager, and if the security manager is null, it can make a new one, or we can just ignore it. And then we do a lookup server and execute. And so lookup server and execute, what we're doing here is we ask the user for the IP address of the server, as instead of assuming that we know it, which in fact that's not a correct address in there. And so then what we'll do is we'll formulate the compute server URL with the IP address, so we can go out using RMI protocol. And then we proceed to get the registry, and we're going to locate a local registry. We'll look up the URL, and then we'll proceed to call the compute server that's computable, and we'll call printline. This is cool. And printline some garbage. And then what we'll do is we'll call compute, which is probably going to return something like this is Doug's computer, and it'll show us what compute returns. If you were to run this without the server running, it would generate an error. You could try it with the local host, but nothing's running. And what it looks like is connection refused. That makes perfect sense. You don't have a server running, so it can't connect to it. So now if you want to, you can go and get the service running. So you go back to the compute server, you rebind with the registry, and it's at serving it at 182. we go back to the client, run the program. He asks for the local host, and he still says it won't work. And why is that? Because localhost doesn't map properly to the 8.2 interface. So let's run it again. That's very interesting. We'll try and put in a proper address, 192.168.1.82, and voila, you've reached Doug's computer, which is exactly what we would expect the compute to return. Moreover, when we go to the compute server, on the server side it says this is cool, and it prints out some garbage, which is just what we'd expect. Now you can stop the server, and that essentially is really all you need to know for basic RMI usage. The call by value versus call by reference, we typically expect to see instances that have been populated being marshaled as parameters through the TCP/IP network. So these are being called by value, and we expect those values to be moved across the network. So if these are heavy values, if they're large values, it's going to take longer. Typically, you would want to have a local call by reference, but when you're doing remote calls, you're calling by value, and you kind of have to, because you can't pass a reference to local memory. Moreover, objects that you're going to push either to the server or that the server is going to return to the client, these have to be serializable, which is another reason they're being called by value, because they all have to be serialized. So if you're passing in an instance of an image, that whole image has to pass across the network. And every single remote method throws remote exception. So in some ways, what we have is modified the call forwarding mechanism that we've seen in the past with a single remote exception that can be thrown for each one of the interfaces. So now you've got a basic question. If you have a whole bunch of classes that you'd like to invoke remotely, what would you do? And of course, you've got to do the method forwarding, and that method forwarding has to be done with a remote exception being thrown on each interface. So we can have a mechanism for synthesizing through semi-automatic static proxy delegation all of the methods inside of a class. But in fact, what's going to happen is they're all going to have to throw the remote method interface. So here's an example where we've got an RMI security manager being created, and then we proceed to look up on the local host the NASDAQ server, which apparently gives us prices. And now the unicast remote object, which implements the stock market server, it allows you to take a symbol, call a price, it gets the price, and then it returns the price as a float, and that's going to come back by value. And what we'd like to see is some mechanism whereby we can invoke this remotely, and presumably it's going to throw remote exceptions whenever it gets invoked. This happens if you get a timeout or some problem at the TCP/IP layer. So what happens is now we've got to make sure get price methods are public. They have to be available outside the package. They have to be compiled on the local server. And we have to then proceed to make sure that they are rebound to the registry. So here we're going to define an interface for RMI hello. And what that's going to do is gives us an subclass of the, or extends the remote interface, allows us to get a message, creates a new interface called RMI hello with the get message invocation that can be returned, and that has to be saved out to RMI-hello.java and compiled. Then we got an implementation which subclasses the unicast remote object, implements the RMI hello interface, has a message that says hello world, and then returns that message when someone calls get message. And notice it throws a remote exception. You can use an RMI compiler to then create stubs, but this is something that you can automate with your IDE. RMI compilers, RMIC, these are things that you can find in the JDK home directory. They enable you to create the stubs automatically, which are used for transporting or marshaling the parameters across the network. Typically, you will determine where the output directory will be, or if you configure your IDE, it'll output it in the proper place. And so I can change the destination option using the RMIC command line however I like. Here's the -d being used to put it out into the Lyon J for P classes directory. Wherever it can be found by the runtime is where you want to put it. It's got to be in the class path, essentially. And you want to create a server class for the implementation. And here we go, rebinding hello to the local registry. And now we're waiting for calls. The naming rebind, that gives you the RMI registry service along with a name on the local host. And so that means this whole thing has to be running, the registry has to be running on the local host now. And then if you don't have a registry running, you can start a registry, although you saw how it's possible to start it within Java by just going and getting the local registry, as I had done. RMI registry is another command within the JDK, so you can just run RMI registry. In fact, we can try and do that now. Let's see if we can find RMI registry in our class path. RMI registry. Yep, it's in there. So now it's running from the command line. If you ask which RMI registry, yep, it's in the JDK. In fact, if we cd to that directory, we can see RMIC is here, RMI registry is there, and there are a few other tools available for us as well. So RMIC is the RMI compiler, and that'll generate your stubs. But any IDE worth its salt will automatically invoke the RMIC for you if it's needed, or at least give you an option to set it up if you need to. So you're going to start your RMI server somewhere using the command line. Me personally, I prefer to do it through the IDE, but you can certainly do it through the directory where the RMI code can be found. And you're going to need to then create a client instance. And here we are looking up on the local host RMI hello. And then we'll proceed to do an invocation. Here it says hello.getMessage. That'll get us a message that says hello world, and then it will print it out. So then comes the big problem. How do you get the bytecodes to the server? I mean, so far we've been doing everything on the same machine. One thing that people seem to like to do is to get the bytecodes by using a base URL and get it from a web server. But that means deployment to the web server is required first. If you're trying to do a distributed system with multiple servers, it might make sense to find a way to centralize this, and we have a paper involving Java Web Start that automatically downloads and runs the latest code using a screensaver. And then comes the big question: how do you wrap existing Java classes using the semi-automatic static proxy delegation? And that is a topic for another lecture. Thank you.